So you know this form xi plus 1 is xi minus f of xi divided by its first derivative in this. So what is the main problem with this method? You know, this is one of the successful methods here. In open methods, this is one of the successful methods we have today. But there is one big problem with this. Problem number one is what? Problem number one is the root must be, the initial guess must be very close, right? So this method is very sensitive to initial guess. If we choose initial guess far from the true value, then we may end up with a divergence in the answer. Okay. So for us, if you want to see any convergence with this method, then always we have to choose initial guess as close as possible to the true value. Okay. What is second one here? The second problem what you have is, okay, drawbacks, I would say, or pitfalls. So I would say drawbacks or pitfalls. Okay. The second one is nature of the function. Not only the initial guess, nature of the function is also important. When I say nature of the function, I say the shape of the curve. The shape of the curve within, within certain domain, that also plays a vital role in deciding whether there will be convergence or divergence. So when I say nature of the function, it is something like this. For example, what is the most headache issue now we have? Anyone? In the formula, what is the main problem you have? You know, not only this one. What is this? Derivative, right? This is derivative. So generally you see, if f of x is a simple function, okay, if f of x is a simple function, then finding out its derivative is no big deal. Yes or not? So this you can do it conveniently. But f of x is it is a very difficult function. I say, when I say difficult function, it is really difficult to show in terms of graph, to decompose things in terms of mathematics, something like that. Okay. If you have something like that, then you will end up with some great trouble in finding its derivative. For example, you see f of x is equal to x square. What is its first derivative here? 2x, right? 2x. So this is very simple. For example, if I say f of x is equal to something, I am taking some random stuff, say like tan hyperbolic, say e power something. I'm just taking something stuff, some random stuff, some ln of this, say multiplied by some, some e power some ln square x cube. Are you able to understand this? For example, f of x is something very difficult like this. Okay, something, it is some difficult stuff like this. Then can you find derivative easily here? Is it possible for us to find derivatives that easy?
No, sir.
No, obviously. So therefore, but in the iteration formula, in the denominator you have this issue. So therefore, if you have a difficult function, finding derivative is a problem. And if you observe one thing, this one also will, will come as an issue. That is what you know. Anyone? What if what if the first derivative is zero? Yeah. For example, you found this at some xi, f dash x at some xi. Now, what if you get zero here? What's the
Not
problem?
defined, sir.
Yeah, the problem is division by zero, right? So division by zero is the biggest problem you have. In computational methods, one of the biggest problems we often take an overlook, is this one only, division by zero. So a good programmer will always take one if condition always. Okay, he'll always take one if condition. If division by 0, then do this, then come out of this, something a programmer must write always. If you see, today you go home, I think I think you have some skills in MATLAB. You have some skills in MATLAB. Otherwise, if you love Python, Python also. If anyone wants Python, they can meet me. I can teach you Python if you want. Okay. So MATLAB and Python, you can do whatever you do in MATLAB, you can do also in Python. But who is the best programming language? If someone asks you, it depends upon the applications. So this is, general purpose language here. This guy is a general purpose language, but he is not general purpose. It is really specific. MATLAB is really famous for engineering and scientific applications than anything else. But this guy is famous for any application. And this is particularly it is script-based language. So this is a script-based language. But what about this one? And of course, hooks is also there with your MATLAB. What about this? Anyone? Anyone? What about this? Anyone? What about this? What do you think of this? Hmm? The beauty here. What is this? Why it is popping up here? Okay, let me put it somewhere here. You can see screen, right?
Yes, sir.
Yes, sir.
Yeah. See, when you come to Python, Python is script-based language. Like C language, Python is also a procedural language, or you can say functional-based language. Functional-based or procedural-based, both are same. Based language, and like MATLAB is also script-based language, and also it is object-oriented programming language. So you can say in one word, Python is all-rounder. I can implement any application in Python, and that any general application, either using programming, I mean procedural-based language, that is functional-based language, or script-based language, like what you do in MATLAB, and also like what you do in MATLAB, it's also OOPS-based language. It's a perfect all-rounder. So therefore, what you do, but of course, if some application is rich in mathematics or rich in algorithms or any mathematical stuff or any scientific stuff, now MATLAB will outperform Python. Outperform means MATLAB is good, superior when compared to Python. MATLAB is very rich in terms of taking care of mathematics. No one can attack mathematics like MATLAB. MATLAB only can attack mathematics that easily, because MATLAB is not general purpose based language. It's some specific oriented language. MATLAB is specifically designed for, I mean, developed for engineering and scientific applications, whereas Python not so much. Can you hear me now? Poor internet connection, I think, from my end. I
Yes,
think
sir.
we got disconnected. I think again we logged in. So This is the problem here. I don't know these days. I know for the last 2 days struggling with this. Some poor internet connectivity. Anyways, whoever want to do real-time projects in Python, okay, then you can meet me for that. Whoever want. It is not mandatory. If you want, you come, you do. Otherwise, leave it. Okay. I don't ask any students if voluntarily if they come forward, I will give. I just give, but you have to do that, okay? I may help you in the middle, but you have to do that. But I will not ask anyone whether you committed or not. It is up to you and I mean your own interest. If you want to do, you can do. Otherwise, you can leave it. It's up to you. But I'm searching for right. I'm searching for right 10 students. Okay, I'm searching for these 10 students and I want to develop one real-time application which is very much required for this society. Okay, and if anyone want to join me, they can come and join. And your class CR has my WhatsApp number. So if you want to ping me up, you can ping me up. And I will create one separate group in WhatsApp for those candidates. And I'll explain you the project and the requirements. Okay, and uh, and your own interest and of course passion. Whoever is passionate about doing real-time projects in using great programming language, they can just ping me up. Santosh, you can give whoever uh, refers you for my WhatsApp number. Just give them. Okay.
Okay, sir.
Okay. Fine. And including you, anyone, whoever wishes to do anything. But this is not by force. If you want, you do. Otherwise, no. I don't. I don't ask anyone if you want to do. Otherwise, not. Okay. So, anyways, initial guess, nature of the function, say nature, I could say shape simply. And if the function nature means I can gone. So therefore,
Sir?
so method is struggling. At those situations, I can think of secant method. Otherwise, it is what is. I mean, the previous method is really good. There is no problem with that method. Okay. I think again it got disconnected. Oh my god, this is a serious issue now, really. So it's getting disconnected at times. So okay. So for example, uh, I have something like this. My scale. Okay. So this is my function say. This is x. This is my f of x or y is equal to f of x, whatever you want to take. I'll take my curve. I'll take my what curve I will take. Let me take a simple curve. Okay. See, the curve is also towards left hand side and towards right hand side, something like this. But I'm not taking all those portions of the curve. I'm taking a curve where the curve cuts x-axis at a single point like this. So this is my solution. I'm taking a simple situation like this. You can make the situation tough if you want. but no big deal. Okay, so now what I'll do, I will take some two values here. I will take, see, secant method demands, Newton method demands how many guesses here? Newton Raphson method demands how many initial guesses? Single, right?
Yes, sir.
Yeah, but secant method demands two initial guesses. So you need not bracket the true root with these two initial guesses. I can take these two initial guesses on one side of the true root. On one side, either I can take towards left or I can take towards right. It's up to you. It depends upon your, approach. But there is a big twist in this. I can also bracket the root using secant method. Okay, but for very few functions I do, but for most of the functions, what do I do? I will give one situation where also we can bracket this true value using secant method, but that still becomes open method only. That's a special case that we will see, of course, in the laboratory only. In the laboratory, we will be having chance of doing all those things. Okay. Luckily, we have labs, so we will do that. Don't worry. So I have, for example, I will take one initial guess x1, and other initial guess, say I have x2 somewhere here. So I have two initial guesses. So at initial guess x1, you find its functional value, okay? And this is f of x1, agree? At x2 also you find its functional value, and this becomes f of x2, agree? Now secant means what here? When a straight line is passing through 2 points of a curve, that is what a secant line, right? Yes or not? Yes or not? Yes or not? When a straight
Yes, sir.
line is passing through 2 points of the curve, then you will be having a secant line. So when you approximate secant line onto one point, that becomes what? A tangent. So the derivative or the slope or the first derivative or the tangent, whatever you call, that is what approximation to a secant line. That means if I make this difference, this is a delta x. If I make this delta x close to zero, then what happens? This secant line becomes a tangent. Okay, so that is what you have, of course, learned in your calculus or differential equations, I mean to say. So I will draw, I don't want this blue. Let me take another color. Which color I can, I'll take white. So this is a secant line. So I have a secant line like this. So the secant line is passing through these 2 points. Point number one, I mean f of uh, x1, f of x2. Now what I'll do here is, I'll do this, okay? Now the point where we are meeting with x-axis, this white straight line is meeting the x-axis at which point here? At some point, and this some point we say x3. Are you able to understand this? See, this is what new estimate. So x3 depends on whom here? x3 depends on two initial guesses, x1 and x2, yes or not? That's the meaning. So the new estimate is x3, all right? So we started our journey with x1 and x2, and using these two, we found x3, all right? And again, using x3 and x2, what I'll do? I will find my x4, yes or not? I hope you're able to understand things, because see, if I find my f of x3 here, f of x3 here, then again what do? Then again I will draw a secant line passing through these 2 points. Agree? I can draw, right, happily. Again I can do this. Let me take one more color. I'll take this color. I took a different color now. Okay, it's somewhat troubled. Anyways, I managed drawing like this. Oh, again gone. Okay, not gone. I'm there. Okay. All right. So are you able to understand this? See now, this orange line is almost meeting this true value, right? Yes or not? Yes or no?
Yes, sir.
Yeah,
Yes,
and
sir.
even fast when compared to Witter's method, I'm reaching towards my true value even faster than that. And also now here, what do I do here? I will in secant method I will not make use of this differentiation anymore. So I can remove the division by zero problem. So instead of taking differentiation, I will take a method called as backward finite difference method. So I call like this. I take a method called as backward finite difference method. So using this, what do? I will replace this first order derivative with a difference equation. Okay, so derivative equation becomes a difference equation. So when you have a difference equation, you will simply make use of linear algebra to accomplish certain things or to solve certain things. All right. See, whenever you have derivatives and all, that becomes a calculus stuff. If I don't have derivatives, that it becomes linear algebraic stuff. So I think you should know this. Anyways, I think maybe in mathematics you have learned, right? So differential equations, you can also approximate to difference equations. So for that, you can make use of forward difference method, backward difference method, central difference method. I hope you know this. If you don't know, there is no problem. We will study these things in unit number 5, part 2. For example, how can we approximate a differential equation to a difference equation? Okay, for example, you see, I can do like this here. For example, you see, what I will do now is this. See, if I go with this f prime xi, okay, the first derivative I can show, how I can show, or I can show it like this, you know. So, for example, anything, okay, anything. Uh, what is this here? I don't know what is happening today. It's popping up, going down, popping up, going down. Okay. Now, first, what I will do, I'll come here, and I will make you. Oh, it's not going. What is this? It's gone. And what is this? It's not going. Oh my god, it's getting stuck. What is happening? It's getting stuck. Okay. Yeah, this will also be out. Is there any break in my voice here?
No, sir.
No, sir.
Okay, okay, but I don't know why it is. Okay, see, it is not responding immediately. I think my video is getting stuck. This is the problem working over poor bandwidth. I am over poor bandwidth now. So therefore, connectivity is a problem and synchronous is also a problem in poor bandwidth. I think this is what you've learned in digital communication and now you're saying, okay. So, okay, I will work out here and I will try to find the slope of this equation. So, okay, so the slope, I want to find the slope of the secant line there from the previous figure. So slope of the secant line. So and that is given by what? I will take this one now. See, I have f of x1 minus f of x2 divided by this gap. Okay, so this slope is equal to f of, I can say f of x1 minus f of x2 divided by x1 minus x2 is equal to, can I take f of x2 minus 0 by x2 minus x3? Can I take like this here? You compare this figure and this. Can I take like this or not?
Yes, sir.
Yeah, how did I take here 0? Anyone? You see this and then tell me. Yeah, why are you taking time? Time is not, I mean, you don't require to take any time here.
On x-axis, f of x is 0.
Very good, thank you. So that's it. Now, what I can do, now you solve for x3. This is enough here. If you have little fundamentals, it's enough. We can venture like anything. So now you solve for x3. Now what you get? Just try to cross multiply these two. Cross multiply these two things, and just solve for x3. So x3 equal to what now? x3 is equal to x2 minus f of x2 multiplied by, you must get like this, x1 minus x2 divided by f of x1 minus f of x2. Agree?
Yes, sir.
Yeah. So once we determine the point x3, okay, so then I can also determine x4, right? Because by knowing x1, x2, we will, I mean, we can, I mean, we found just now x3. Similarly, by knowing x2, x3, we can also find x4. So by knowing x3, x4, we can also find x. That means new estimates we can. Shagaru, కొంచెం light వేస్తారా? Okay. పర్వాలేదండి చాలు. ఓకే. అది ఆపేయండి. లైట్ ఒక్కటి చాలు. అది ఎందుకు ఇది ఆన్ కావట్లేదు మరి? So yeah, sorry. So I was asking about light. Okay, anyways, so based on x1, x2, we have constructed a form for x3, the estimate x3, okay, like x2, x3, using which you can find x4, and we keep travel like that as our iterative estimates. So therefore, what I say, okay, I can say like this. So iteratively, see, this is very, this how computer process are simple here, really. Yes, sir, they're very simple, right? Once you understand the method or approach, that's it. You can do anything. There is no big deal in that. So I can say, which color I can take? I can. It's getting stuck. I don't know why. I don't know what's the trouble. Okay, so I'm habituated in taking new iteration as xi plus 1. Okay, so when compared to xi plus 1, here what do I have? If it is xi plus 1, this is xi, right? So therefore I take xi here. So this quantity is xi minus, okay, if it is xi, this must be also f of xi. Agree? So it's a convention here, nothing else. If you take this is xi, you take here xi minus 1. Okay, that depends on you. That's the convention. F of xi, so multiplied by, see, I have x2 here, but x1 here, I have xi, so I could say this is my xi minus 1, and this is my xi, divided by, see, this is f of, so whatever I have in square brackets, you take it the same here, f of xi minus 1, f of xi. Are you with me? Did you understand this?
Yes, sir.
Yeah, that's it. So once you know how to find x3 from x1, x2, you can progressively iterate to this general form. So this is your final general form. Okay. Now I did something strange. If you observe carefully, I did something strange. So knowingly or unknowingly, we have applied this strategy, okay? The differentiation stuff, the derivative stuff in the Newton method. Okay, anyways, I think I removed that somehow. Okay. So according to Mr. Newton-Raphson method, or I can simply take Newton's method, I have the new estimate xi plus 1 is equal to xi minus f of xi by its first derivative at x equal to xi. So say designate this one as 1 and this one as 2. On comparing Mr. 1 and Mr. 2. So what do we get? Anyone? On comparing these two stuffs, so I'm not really understanding why today it is torturing me. It's not letting me to move from one option to other option. It is causing a hindrance, okay? So on comparing 1 and 2, I could say f prime xi is xi minus 1 f of xi, okay, divided by xi minus 1 minus xi. Is it right here? Can I say like this?
Yes, sir.
Yeah, and you see here you have xi and here you have xi minus 1. You are subtracting xi from xi minus 1, and therefore we could say this stuff is called as backward. Okay, you are subtracting xi from xi minus 1. This stuff is called as backward. Fine, of course, it's a finite, backward, finite difference method. So differential we converted to what? Difference. Yeah, this is difference. Yes or not? So this derivative we converted to difference equation now. So this is backward finite difference method. Yeah, so you have to observe this first of all. Did you all observe this? If you all observed this, that indicates that you are with the algorithm. Okay, and the main drawback of Newton's method, now you overcome with this secant method. Yeah, clear, everyone?
Yes, sir.
Yeah, that's great. So now, and that's what you have done. So that's what you have done here. So that is in place of this. Otherwise, in place of this. So if you put this guy directly, you will get this. Either of the things is okay. So in place of this, if you put this, you will get this one only. So anyways, we are successful in finding out a method, an approach using secant method, and also you have modified secant method.